This is the Redfish 2025.2 release webinar. Welcome, everybody. This webinar is being presented by the Redfish Forum co-chairs. My name is Bill Scherer. I'm with HPE. And we have also the other co-chair, Mike Ranieri from Dell. Mike, why don't you say hello?
Hi, everyone. Yep. So I'm Mike Ranieri, and as Bill just said, I'm the other co-chair of the Redfish Forum.
So this is the Redfish release 2025.2, which is now publicly available. So in this release, we have an errata update to the Redfish specification, which contains a few things. We've added some guidance on e-tags to enable you to avoid unnecessarily frequent updates. So some more information on properties not to include in the e-tag calculation. We have corrected the ST header to allow SSDP to align with UPnP. And then finally, we have added some guidance for the @message.extendedInfo response to put and patch operations to be able to limit the amount of response traffic coming back to those operations, which is particularly important in RDE implementations. We have an update, the 2025.2 release of our Redfish schema bundle in DSP 8010 with all of the updated and released Redfish schemas. This, of course, is the main bulk of the release. We also have an update to the Redfish message registry bundle for, again, release 2025.2, and DSP 8011 contains all of the updated registries. We have a new automation node event message registry, as well as additional messages in platform registry version 1.3.0, which adds messages for PCIe, memory, power, and various device conditions to be able to communicate the status of those items. And then finally, the environmental registry version 1.2.0 is updated to add thermal equipment subsystem messages. So as usual, the bulk of the update is in the schemas, and we have 8 new schemas: automation instrumentation, automation node, job document, and job executor are all related to the automation that Mike will be talking about in a moment. Telemetry data is more information for Redfish telemetry. Update service capabilities was added in relation to our firmware update staging, which I'll talk about later. And then finally, the virtual CXL switch and virtual PCI to PCI bridge schemas were added as an extension of our CXL support. In addition to the new schemas, we have updated 36 individual schemas, and the full details of all of those updates are captured in the release notes inside DSP 8010. Some of the highlights were extending the update service and software inventory to support bulk activation of firmware images, extending job to support job creation from reusable job documents, and then adding Modbus support for aggregation source, connection method, manager network protocol, and serial interface. And as usual, all of the material that we've published is available on our standards page at http www.dmtf.org/standards/redfish.
Okay, thanks, Bill. So first, I'll get into some of the details about automation nodes. So we've added 2 new resources for modeling what are called automation nodes, automation node and automation instrumentation. So these are to represent pieces of equipment that you might find in industrial IoT environments. So think smart factories. This was a contribution that came into DMTF through PICMG, and there was joint work involved to flesh out the model a bit more and make it comprehensive to both organizations. And so an automation node represents a controller or some type of aggregator to control the motion of equipment in a factory. And this could be things like mixers, robotic arms, motion controllers. And so what we've done is we've created a new automation node collection off of service route, and then each of these pieces of smart equipment have their own automation node resource and their own instrumentation, which are effectively akin to metrics in other areas, but it also includes the controlling operations around the device. So within the new automation node resource, it provides all the smart sensor and smart controller metrics and behaviors that align with the industrial IoT and factory automation applications. And so this was designed to be compatible with the PICMG IoT.1 device firmware specification. So these devices that they all conform to a spec that's delivered by PICMG to describe how to integrate into these smart factory environments. Some of the highlights in here, there's a node type property that explains the purpose of the node and how to use the control and sensor data within the automation node instrumentation resource. So there's things like a simple type of node where you have a basic control instead of sensors. You might have a PID-based controller, which allows you to specify parameters around how that device operates. You have different types of motion and velocity controllers, or you may even have a group of controllers all working together as a single cohesive unit. So that's described as a motion position group. Think of like a multi-axis robotic arm. Node state tells you what is this controller doing right now in terms of am I carrying out an instruction? Am I waiting for the next one? Am I completed? Did I hit an error condition? And then there are actions directly on the node to advance the state to, once it's given a command, okay, I can go start that movement, or maybe I need to stop it right now, or try to reset the device, or send some type of interrupt through a trigger to the node to make it do something different. A couple of other properties like motion profile to help control what type of robotic motion the device is going to be moving through. Right now it's defined as it can either be trapezoidal type of control motion and an S curve, or if there's simply none, and it's just left to the implementation to figure out. So as part of that grouping, there are ways to kind of group multiple automation node resources together to form that singular group. It's kind of like how you can have multiple sensors feeding into a single synthetic sensor reading. So you could have multiple automation nodes grouped together to create a single logical node. So you can command that entire set all at once. Within the automation instrumentation, this gives you the lower sensor and controls for that type of device. And like with all of our other excerpts, if you need to go off and get more information about that controller sensor, you can follow the data source URI link. These properties, there's a lot of additional properties within here, and you may expect to find some based on the type of node. So there could be motion-based sensors and controls for the motion type of nodes. And then there's also just the lower order readings of the device itself. So if there's a need to see if the device is misbehaving, overheating, if there's anything wrong with its environmental, you can extract that information directly. Going in through jobs, this was paired with the submission that came in from PICMG for automation nodes as part of their industrial IoT applications. There was a need to be able to easily script up jobs that can be carried out by the factory. And so the proposal that came in was to create a new job document resource that describes a recipe for what the different nodes can carry out in terms of producing a widget or a thingy. This allows a user to say, I have a specified job document. I may insert a few additional parameters to specify things like the quantity, shapes, color, or some other additional options. And you could press a button and carry out the production of that type of widget. Job executor, it describes who in the factory is carrying out the operation. So you might have a server inside of the factory that is overseeing the motions of all the pieces of equipment, and they may be capable of performing certain types of jobs based on what their capabilities are. We also had to extend the job resource to support these new document-based jobs. So a single job resource still represents an exact instance of a workflow being performed, and we added a few new steps to the life cycle to support this job document based type of flow. So we added validating and invalid values to job states, and so before you can even start the job, you need to be able to verify that, am I even capable of producing this? Maybe I'm running low on material and I have to alert the user that, no, I can't do this right now. You need to go order more raw material. And then there are additional actions to control the state changes in the job itself. So if you advance to a new part of the job and you need to wait for the user to acknowledge that, there are new actions to help control those states. Going into the example, so this is an example of a new job document. We have an action in here called submit job, and this is how you can instantiate a new job resource from a document. And so you would perform the submit job action and provide the additional parameters, and that would go tell the factory to start queuing up new work. There's also a couple different properties for showing metadata about the job. So, what type of document is this? What's its version? If I want to go look at the document itself and understand what the workflow that's involved, I can go download it potentially. We also have our parameter metadata. So this is used when you're doing the submit job action. If you want to specify things that are optional, or rather things that are controllable through the new job. In this case, we have 3 parameters. Number of pieces. So this is a candy document. As part of this, you're required to specify this parameter. We give a flavor, and so there's various flavors you could instruct the job to add to the candy, and then there's also the shape. So 3 parameters that can be specified. And then we also link to the supported executors. So when you need to start distributing the work, you might want to specify, which executor you would prefer this to be carried out by. And so this tells you what you're allowed to specify in that request. For the job executor, we have just the basic name of the executor, the maximum number of jobs that the executor can carry out, and then links back to what jobs is it currently carrying out. Am I part of a system or a chassis? So linking over to the kind of the more the IT side of the world to see who is actually performing this job, or who can who this job executor actually is. All right, moving on to device telemetry. So we added a new telemetry data resource to allow an external user to extract large amounts of data from a device. This doesn't replace the existing metric reports that are done by Redfish. This instead allows a user to simply reach into a device, pull out as much data as possible, and present it back to the end user. And so many of these devices don't really, many of these readings may not directly map to Redfish, and it's more of a burden to do that mapping just to bring it to a metric report and have it reassemble back in the original format. So why not just let the user collect the data directly? There's a new collect telemetry data action on telemetry service to allow a user to trigger the collection of this data from one or more devices. And so the response to this action tells you where that user can download that telemetry data afterwards. So the way it works end to end, the user would start with a post to the collect telemetry data action. It would specify the type of telemetry data they're trying to collect. And so there are many different formats. Largely, this is OEM for now. Um, uh, in the future, we do anticipate there will likely be standardization of the telemetry data formats, but for now, devices tend to create their own vendor-specific definitions. And then the set of links to the target devices from which you want to collect the data. In this case, we're saying I just want data from this one processor found under sys1. You could have an array of devices, so you can get an array of telemetry data coming back. So the response would tell you which telemetry data resources were instantiated to contain that data. So when this is all done, a user can go through the telemetry data list and go to each of those URIs to start downloading the information. So when the user does that, there's a couple of pieces of information found inside of the new telemetry data resource. You have the data type, so you can understand the format of the data when you extract it out, and then you have two properties here: additional data and additional data URI. Additional data can give you the full telemetry data that was extracted if it's small enough. The reason for this is once you start getting into the megabytes of data, it becomes quite burdensome to stick that all within the resource itself, and so the pattern that we've fallen into with some of these other raw data types of properties is, if it's too big, redirect the user to a URI that's not a resource, but it just gives them the full raw data that's not even encoded in any format. All right, moving on to Modbus aggregation. Modbus is still a thing, and there's a need to be able to configure a service to point to different Modbus entities and start aggregating data from those sources into its own model. So we've added a few extensions to the model within under the aggregation model. The connection method type property was extended to allow for Modbus TCP and Modbus serial. So you could say I want to go to a URI that has a Modbus service behind it, or I need to specify a serial port that goes to a device for collecting Modbus information. There's also Modbus target server ID added to aggregation source. That's because over a single URI or a single serial port, you could have multiple devices downstream, and so you would have you'd specify which server you're trying to access on that single interface. Within serial interface and managed network protocol, we added a Modbus object to configure settings for the Modbus interface. And then under serial interface, we added a few specific Modbus values to pin out to further describe the physical structure of that serial interface and how it's used. As an example of how a user would specify to aggregate a Modbus TCP device. First, to remember, within the aggregation service, there's really a pair of resources that work in conjunction. You have connection methods, which shows what the service supports for aggregation. So it would be the way to advertise that yes, I support aggregating through Modbus TCP or from another Redfish service. In this case, we have a new connection method here showing, yes, I support Modbus TCP. In the links, this shows the aggregation sources that are currently using this connection method. And so the aggregation source shows an exact instance of where you're aggregating data from. And the example on the bottom shows that, yes, we have a new aggregation source. It's using the Modbus TCP connection method. I'm pointing it to some host name for accessing the data. And importantly, I'm assigning it a Modbus target server ID, since that's part of the Modbus protocol for accessing the device. Very similarly with Modbus serial, you have that same pairing of connection method and aggregation source. So to show that you support aggregating from a Modbus serial interface, you need to have a new connection method resource that shows the connection method type is Modbus serial. It also points off to the physical serial interface from which you'll be doing this aggregation. And then on the bottom is the exact instance of the of aggregating from a source. So it's referencing back to the connection method for Modbus serial, and it's also specifying the target server ID. Okay, moving on to subsystem conditions. There was an ask to be able to start to break down the health of a large resource like a system or a CDU to be able to show the status of the different subsystems in the device without having to go into the subordinate resource themselves. We do have health rollup in status today, but it takes extra work to be able to say, well, I see a degraded health rollup, but why is that health rollup degraded? Can I attribute it to a single subsystem? How do I break that out to the different display panels for what's starting to degrade the health? So to help solve this, we added a new property in conditions called condition type. And so this is to distinguish between a subsystem health versus just a regular alert that something is broken. And so as a service can statically show subsystem health messages and conditions. So even if the subsystem is okay, you could see that, yes, my subsystem under this this large resource shows okay, and I can kind of break things down to different buckets that way. And over time, we'll be standardizing messages that go into these subsystem categories. We started with the environmental message registry, since the request was for supporting this on CDUs. And as needs grow, we can expand that list. So the way this would look in a live service, so taking the CDU as an example, you see at the top, the health rollup is critical, so we know something is broken, but can we categorize that into a subsystem that's broken and show green for the other subsystems? And so we see here, the first condition message shows the pump subsystem health is critical. So we know right off the bat here that my pump subsystem is critical, so I can populate red for that area of the dashboard. We do see subsystem type, condition type here is marked as subsystem, and we do show, where if you need to drill deeper, where to go off and start querying information. We also have right next to it the pump failed message showing condition type alert. So this shows the individual thing that's broken. And so we have this with conditions today. You could show your failed pump right in the CDU resource today. But here we're also showing that this is an alert. This is something that we just populated now because there's a broken pump. And then if we look at the other two messages. They're both for subsystems. They're both showing a severity of okay, meaning that these subsystems are healthy. So we have a secondary coolant connector subsystem health and a filter subsystem health. And so in this case, you could show your dashboard for your CDU with 3 different color codes. You could show red for the pump subsystem that's broken and green for these other 2 subsystems. All right, and so I'll pass it off to Bill now to talk about stage firmware updates.
Okay, thanks, Mike. So, yeah, so the next update that we've got in this release is for support for staging firmware updates, which is the process of putting a piece of firmware onto a device without making it immediately active. And this allows you to there are multiple use cases for this. You can use it to put a backup piece of firmware on a device. You can use it to pre-populate the firmware across multiple devices and then do a coordinated migration to a new firmware. So the implementation consists of adding a stage parameter to our simple update and multi-part HTTP push update processes in our firmware update process for Redfish. And so, as I said, certain environments want to flash the new image without activating it immediately. And so the stage parameter lets a client specify whether the piece of firmware that's being flashed down to a device should be activated immediately or whether it should be just put down there and into a ready state. We have our new update service capabilities resource, subordinate to update service, which allows target URIs for those update requests. And then in our software inventory, we've added 4 new properties. Active and stage correspond to the whether a individual piece of firmware is currently active and running, or whether it's staged, ready to be activated. And then there are lists of all of the pieces of software that are active, that's active targets, as well as all of the pieces of software that are ready to be activated, and that's the staged targets. And so this lets a client view the status of how images are installed on the devices. Finally, in the update service and in software inventory, we've added an activate action, which allows a client to explicitly specify to transition to a staged image on one or more of the devices that have that staged image and make it active. Next, moving on to CXL, we have extended our CXL support to support CXL switches that can contain virtual switches as well as virtual PCI to PCI bridges, which are used by fabric managers to control switch configurations as well as downstream port binding. So the virtual CXL switch resource defines a standard CXL-based virtual CXL switch. It contains a collection, or our switch resource now contains a collection of virtual CXL switch resources. And it replaces the previous VCS property that was in switch. Our virtual PCI to PCI bridge resource now describes the CXL virtual PCI to PCI bridge, the VPPB entity. And the virtual CXL switch resource contains a collection of those PCI to PCI bridge resources, each of which captures the link between two endpoints and PCI. So as usual with the release, we have created a series of schema and registry guide documents. The first of these is, of course, the Redfish data model specification, DSP 0268. This is the document that once upon a time was titled Redfish Schema Supplement, and includes all of our normative statements, which are the long descriptions, as well as informative description details from the schemas in a single document. And this is really intended for use by service and client-side developers. The long descriptions are sort of the formal specification aspects of all of our properties. The next document is our Redfish Resource and Schema Guide, DSP 2046. It presents the schema and data model contents for Redfish in a format that's much more friendly for end users. And it also includes example payloads for each of the resource types. So both of these documents that I've mentioned are much easier for most people to read than the raw schemas, which have gotten increasingly complex and difficult to read. The next document is the Redfish Message Registry Guide, DSP 2065. So similar to how the previous two documents detail the contents of the data model, the schemas, this one explains the contents of the message registries, again in a more human readable format. And again, it includes a summary table as well as details on the individual messages. Lastly, we have the Redfish Property Guide, DSP 2053, which is intended primarily for people who author schemas. And it provides an alphabetical list of every property defined anywhere in a Redfish schema, and makes it very useful to locate existing definitions or properties, and helps us to avoid redefining property names that are already in use. So the Redfish Publications repository is a public GitHub repository that contains a hardened copy of the that is read-only of all of our schemas and registries. It is available at https://github.com/dmtf/redfish publications. We update it with each release and freeze it at those releases and only update it at the release time. So it doesn't contain the work in progress that is in the private tree. And so it is available as a resource for anyone working with these resources. So it creates public durable locations for referencing schemas or registry items, either in issue reports or in forum postings or any other online references. And it allows developers to automatically synchronize with new releases using standard GitHub tools and process methodologies. So again, this repository is updated each time a Redfish release becomes public. We have updated it already for the 2025.2 release. And it contains all of the material published that in DSP 8010 and 8011 in all of the different formats. So CSDL is the Redfish schemas in the OData CSDL XML format. /JSON schema is all of the Redfish schemas in JSON schema format. /OpenAPI is the Redfish schemas in the OpenAPI YAML format. /dictionaries is the RDE dictionaries, which are actually a form of schema. And then finally, /registries is all of our standard message registries. We have several available Redfish conformance testing tools. So the Redfish Forum provides a series of open source tools for service developers to validate their conformance with Redfish protocol, data model, and profiles. We've got our Redfish protocol validator, which allows you to test a service for conformance to the Redfish HTTP protocol itself. This includes both response headers as well as all of the various status codes, which is available at https://github.com/dmtf/redfish protocol validator. We've got our Redfish service validator. This lets you test a live service for conformance with the Redfish schemas, ensuring that the JSON payloads you return are able to validate against our standard data models. We strongly recommend that developers run this tool first, as errors in payload are much more likely to cause issues for end users and for interoperability. This tool is available publicly at https://github.com/dmtf/redfish service validator. And then finally, we've got our Redfish interop validator, which lets you test a service against a Redfish interoperability profile, which allows you to confirm that you've implemented all of the properties and actions needed to meet a series of requirements for a customer or a use case. And this is available publicly as https://github.com/dmtf/redfish interop validator. And so now we can go into the Q&A portion of this webinar. And so we have received a couple of questions from the pre-registration. So let's start with this one. What simulation environments does DMTF or a partner service provider offer? I would be interested in testing updated schemas. So, yeah, go ahead, Mike.
Today we don't have a real simulation environment from DMTF. I'm not aware of any third parties that might offer that. We do have tools that might come close. We do have the Redfish mockup server. So if you're just looking to serve static JSON files to a client, that would be something that might be of interest to you. It is available on GitHub as the Redfish mockup server project. So you could point it at a mockup directory and it acts as a Redfish service. There's a more comprehensive, or rather more capable Redfish interface emulator, also hosted on GitHub. That allows you to serve static mockups, but it also allows you to write code behind the scenes to simulate what a service may do in different conditions. Like if you patch a property, or can you trigger it to go off to different states and affect other resources. So it can be more comprehensive if you're willing to put in the work to offer that simulation. I know SNEA has forked the Redfish interface emulator and created a Swordfish emulator. That has more capabilities baked into it today. That's the extent of what I know about for simulation and emulation.
Thank you, Mike. We have another question that was pre-submitted, so we'll run through that one, and then we can take questions from the audience. So this question is, what would be involved in DMTF providing an efficient Redfish metrics exporter for subsets of Redfish metrics configurable for various use cases into standard Prometheus-style time series databases, such as Prometheus or Victoria metrics?
Yeah, so I know telemetry is it's a rather big subject. Everyone's interested in it. I've certainly heard from various folks the desire to export directly to different telemetry databases. OTel is the other one I hear come up frequently. At least as of today, if for the current Redfish model and protocol is all tailored around building metric reports and sending out events with the metric reports themselves, which can be in order to make that work with other databases, that would mean you need to make a plugin that can take that metric report data structure and put it directly into that database. I do know at least one vendor has done that for OTel, which is great. I think that can be leveraged by other folks, but there's also still the desire of natively doing this, so you don't need those plugins. The issue we have right now is, we don't have any formal proposals to make that work. So if someone would really like that type of capability in Redfish, what we'd really look for is a proposal for telling us how to actually do that, standardize it, and make it interoperable across different Redfish services. That's
Yeah, it
been
would
one
be
of
really great if a
yeah.
subject matter expert in one of these could come in and help us out with that.
Yeah, we're more than open to that. It's a lot of it comes down to can someone do the technical homework to make that a reality, and very importantly make it interoperable, since one of the pain points with some of these data streams is if we define it one way, it could be implemented 5 different ways, and then the interoperability breaks down across the ecosystem.
So that was it for the pre-submitted questions. Are there any questions from the audience? So you can raise your hand to be unmuted if you have a question.
I'm not seeing anyone.
I'm not either, so let's go ahead and proceed. So we know that all of you would love to get involved in Redfish, and so there are lots of different ways that you can do that. So there is, of course, our Redfish standards page if you just want to see what we are all about. So we've got all of our schemas, our specs, our mock-ups, all of our white papers, the message registries, and everything else. And that is at http://www.dmtf.org/standards/redfish. If you're a developer, we've got our Redfish developer portal, which has our interactive resource explorer. It's got a whole series of educational material, documentation, and other links. And that's available at http://redfish.dmtf.org. We have our Redfish user forum where you can post questions and directly communicate with us. This is great for suggestions or discussions, and we would encourage you to come there at any time with questions. This will require you to register for an account, but that's a very painless process, I assure you. And that's at http://www.redfishforum.com. We also have a feedback portal for more formal feedback or for proposals for new Redfish standards. And this is at https://www.dmtf.org/standards/feedback. And then finally, if you want to actually join the DMTF and get involved directly, you can join the Redfish Forum. Get your company to join and be directly involved in the future work. And then that would be http://www.dmtf.org/standards/SPMF. And so thank you all for attending. This will be the end of the recorded session of this webinar. And so I would like to take a moment to thank Shannon Keith for lurking in the background and keeping everything running smoothly.
Thank you, everyone.